got some fantastic speakers, and our first one is Will Steffen, Professor Will Steffen, who for 6 years directed the International Geosphere-Biosphere project in Stockholm, is the Executive Director of the Climate Change Centre at Australian National University and is Science Advisor to the Department of Climate Change of the Federal Government. Please welcome Will.
Thanks very much. I guess I'm the first one who gets the opportunity to scare you a bit this morning. Try not to be too harsh in that regard, and I'll also see if I can manage the computer. Anyway, what I'd like to do is organize my talk around the concept of the Anthropocene, which some of you may have heard of. That's a geological sounding term, and it's a term that Paul Crutzen first used about 8 or 9 years ago. But it signifies the fact that the Earth is now moving out of the geological state it was in, and is doing so not because of any natural forces, but because of human activities. In fact, this is becoming so widespread that the Geological Society of London, which formalizes the epochs and eras that the Earth goes through, is now set up a working group to consider whether they will officially declare that the Earth has left the Holocene and is now into the Anthropocene. I'll present now the evidence for that discussion. So the Anthropocene era, well, it started at the beginning of the Industrial Revolution, but as I'll show you in a few minutes, it's really taken off since the Second World War. The one that everyone talks about, and I guess we all need to start with this, is climate change. And you can see on the graph there a nearly 2,000-year temperature record. You don't often see temperature going back that far, but we can use proxy data to see what the Earth was doing in the past. This is a northern hemisphere surface temperature record. We don't yet have a southern hemisphere one to correspond with it. But anyway, if you look at all the colored lines, those are various proxies, various estimates of what the natural variability of Earth's climate is in terms of temperature. And you can see it wobbles around a lot. You can see the medieval warm period. You can see the little ice age that people like to talk about. But the red line at the end is the instrumental record of the last 150 years or so. And you can see that's different in a couple of ways. One is it's rising much faster than anything else that we see in the last 2,000 years. And if you go up to the end of that red line, it's already just moving outside the limits of natural variability. So we're starting to see climates that we haven't seen for several thousand years. In fact, we could go back probably for about 6,000 or 7,000 years, certainly since the advent of human civilizations. And we can see other manifestations of that. This is the famous Arctic sea ice shrinking, satellite imagery from 1979 and 2003, and the shrinkage has accelerated after 2003. This is one of the bellwether signals of the fact that the Earth is now shifting very fast in its biophysical characteristics. Ice is shrinking at a fairly high rate. But I want now to talk about other aspects of the environment, because there's a lot more to what's going on to Earth's environment than climate change. They interact with climate change, but some of these are simply direct human impacts. This is a good example. This is the cod fishery off Newfoundland in Canada. And you can see from 1850 to 2000 the catch data that people have been collecting. And you can see that the fish catch has gone up year by year rather gradually until just after the year 1950. And that year 1950 will come up again and again. And suddenly it shot up. And that was due to the mechanization of the fishing fleets. Unfortunately, the people who were fishing forgot that they were dealing with an ecological system and not just some process, manufacturing process. And so fish catches went up. They thought that they were in very good shape, making enormous amounts of money. And then the system crashed. It recovered a little bit after 1980, and then it crashed again down to zero. There's no cod left in that fishery. And it's interesting that it wasn't until 1992 that they actually stopped fishing. It took that long to work out that they were really in trouble. So you can see that human response times are oftentimes too slow to really prevent disasters like this. But humans are basically terrestrial creatures. We live on land, we breathe oxygen in the air, we don't breathe oxygen in the ocean. So it's really the land surface that we've transformed more than anything else on the planet. You can see all the way from whole landscapes, which now look like industrial landscapes, down to the very genetic material on which we depend. We're manipulating at all scales the biological and ecological systems on which we depend. So the human imprint on land is very strong indeed. We can also look at our imprint in different ways. This is an example of how economic globalization, which you tend to think of in terms of trade and dollars and cents and commodities moving, are actually moving a lot of the biogeochemistry of the planet now too. I could give you a similar one for nitrogen and phosphorus. This one is water, or virtual water flows. So this is water that it took to grow cereals. So in a way, it's embedded in the cereals that have been transported around the planet. And you can see that there are a couple of important net exporters of water. North America is the biggest one by far, and it sends its cereals to many other parts of the world. But notice, of course, that Australia also is globally a significant exporter of cereals, and through that, of virtual water. Now, it's quite interesting that we're the driest inhabited continent on Earth, and yet we export large amounts of our water to other parts of the world. So if you look at what we call global change rather than climate change, we can see it in many different ways. There's the nitrogen cycle in the upper left. The top panel is the natural nitrogen cycle before the Industrial Revolution. You see one huge arrow, N2, with the number 100 on it. You don't need to know what the units are, going down from the atmosphere into the land surface. That is natural fixation of nitrogen by biological systems. And then if you look at the nitrogen cycle now, you see that arrow, but you see it's now matched by another huge new arrow coming down in the center. That's human fixation of nitrogen. So we've actually perturbed the nitrogen cycle more than we have the carbon cycle. You hear a lot about the carbon cycle these days, CO2 emission reduction. It's very important. But bear in mind that we have actually changed other element cycles more than we've changed the carbon cycle. Nitrogen cycle is one of them, and the phosphorus cycle is another one. Now, once that nitrogen, which is now in a reactive form, gets into the system, you see all the other arrows on that diagram are changed. And that, so the initial human perturbation flows through the entire nitrogen cycle, in waterways, in soil, and back up to the atmosphere. We can see the human perturbation of the hydrological cycle. These red dots are where large dams have been built around the world. We're now intercepting about half the water flow to the ocean and using it for various human purposes. The bulk of that is what I showed you earlier, embedded in food production. About 70% of fresh water used by humans, by the 6.5 billion of us, goes into producing our food. Relatively less goes into direct human consumption and in manufacturing. And if we look at land cover, these areas that are shaded in here are areas where there are intensely cultivated systems, areas in which at least 35% of the landscape is cultivated. And so again, you see our agricultural belts there, but you see large areas of Asia, huge areas of North America and Europe have been turned over to cultivation. Basically, the areas that are not cultivated are either too dry or too cold, or at least too cold at present, to be cultivated, apart from the large tropical rainforests. They're the last bits left that haven't been converted, but they are being lost. And then, of course, we can look at the climate system, and there are many aspects of it. I don't have time to go through the various aspects in which the climate system is shifting, one of which is extreme events and storms. There's the classic photograph of Hurricane Katrina of 2005 as it's coming into the Gulf of Mexico and heading for New Orleans. And then the iconic image, of course, of global mean temperature inexorably rising with a few ups and downs, but the trend is very clear. It's going up. So all that put together is global change, and it interacts. How we use land interacts with climate. It affects climate, is affected by climate. The nitrogen cycle interacts with the carbon cycle in many different ways, and so on. So part of the challenge to us in the scientific community is trying to understand the Earth as a system, how all of these pieces fit together. We tend, as a human society, to put things in silos. That's what we've been doing for 400 or 500 years after the advent of modern science. We tend to go narrower and narrower. We now need to start putting that together and understanding our own planet as a system. But I want to now talk a little bit about Anthropocene Stage 2. Now, Anthropocene Stage 1 arose when we started accessing fossil fuels. And we had an entirely new energy system which broke us free of using a little bit of wind, a little bit of water, and a lot of animal and human muscle. Once we did that, that completely unlocked a lot of things, a lot of possibilities for humans. Now, you can see that quite clearly. What I've done here is I've put on the same graph from 1750, before the Industrial Revolution, to 2000, a number of aspects of the human enterprise. This isn't an environment. This is what we as humans do. So there's population, economy, foreign direct investment on the top, and there's some resource use, damming of rivers, water use, fertilizer consumption, paper consumption. I put in McDonald's restaurants. I wanted one indicator of globalization. That turns out to be a very good one. And then you have transport, communication, tourism, and so on. Now, the thing to note on these graphs is that they're linear. The vertical scale is linear, so it does not hide accelerations or changes in rates, which are very important. A lot of people tend to use log scales, which tend to mute down the real effect that the Earth, if you like, really feels. But notice the year 1950. In every single case, things really happened after the Second World War. In terms of population, you see it taking off after the Second World War. Look how even more dramatic is the growth in the human economy after 1950 and resource use. And several things didn't even exist to any extent before 1950, things that we take for granted, like motor vehicles. And just coming in from the Melbourne airport this morning trying to get here, it just again reminds you how over-dependent we are on motor vehicles. We didn't have any telephones before 1950. Now do we not only have telephones, a lot of people have 2 or 3 of them, one for each hand and one in the pocket. And international tourism. Until 1950, virtually none of us took holidays overseas. Now, again, coming into Melbourne Airport, look at the number of 747s, now A380s, 330s, loading up to go to various parts of the world. And that's not unusual for any of the major airports around the world. So things really shifted after the Second World War. Now, again, I don't have time to go through why that happened. It's an interesting field of research in economics and social science. But in fact, we got some good clues as to what happened there. But the thing I want to point out here is now when you look at the biophysical part of the Earth, you can see, again, changes since 1750. Now, you don't quite see the 1950 break in all of those so clearly, and there's a reason for that. There's a very strongly nonlinear relationship between pressures on the Earth system and how it responds. In many cases, it's buffered, and you don't see a change for quite a while, and then you might see a sharp change. And you can go through and see what we've got there, the famous greenhouse gases, a couple of indications of climate, temperature, and floods. But then the biogeochemistry here, you see nitrogen going through the coastal zone, numbers of fisheries depleted, and some biodiversity and land issues there. But in each case, you see that the human imprint is well above natural variability. You don't see some nice little wavy patterns with a small human imprint. It's well above natural variability in all of those parameters. So that's the challenge we face. What does this mean? What does this mean for our global environment going into the future? We can measure this in a very rough way, but I think an interesting way, by looking at what's called a global footprint of the human enterprise. And it's a very simple calculation, really, just an indicator where you take the amount of land and the amount of sea it takes to support a human to produce what we consume and to absorb the waste that we produce, like carbon dioxide, for example. And of course, it varies depending on where you live and what your lifestyle is. Those of us in Australia have much bigger footprints than those in developing countries. But globally, you can see that since 1960, we've gone from using half of a planet Earth, that's the scale on the left, up to about 1.2 planet Earths. In other words, we're an overshoot, and we're eating into the capital of the Earth rather than living on its interest. If you do it by country, fascinating graph. Again, I don't have time to go through it in detail. But here we have the global footprint on the left. That dotted horizontal line is the capacity of planet Earth, with no area set aside for wild species. If we could consume all of Earth's productivity for humans, we'd be up at that dotted line, just below 2 hectares, global hectares per person. And you see that the USA is way above that. Australia is also way above that. The Europeans aren't quite so bad. It's the poor countries who are living within the means of planet Earth. The sustainability quadrant, this horizontal axis, is the Human Development Index. We all want to improve human welfare. That's why the wealthy countries slide to the right, but they also shift upwards at the same time. There's only one country that just sneaks in, having raised its human welfare up to what's considered a reasonable standard without going above the biophysical limit of the Earth. And at the end of the talk, I might let you guess what that one was. Okay, I'll just close now with some few words about where we're going. Anthropocene stage 3. We're entering a new stage, and that's because we have self-awareness, the fact that we are changing the planet. Things are happening to climate, things are happening to biodiversity and so on, and how we're going to deal with this. So we know we've become self-referential actors in planet Earth, and so it's what we call stage 3. And one of the big questions people ask is, are we headed for collapse? A lot of societies have collapsed in the past. or are we headed towards sustainability that everyone's talking about now? Well, that's an interesting scholarly question. And you can look at past societies. This happens to be the Greenland Norse society, which is one that collapsed. There are many others that did collapse. And it was often thought that they simply did not realize, or when they did realize, could not change their core values, could not change their institutions, could not deal with the pressures that were impinging on their societies. And the question is, will we end up any better than the Greenland Norse? Now, in the past, there was a big difference. These were all regional or local. And so as societies collapsed, populations could disperse and move somewhere else and rebuild. Well, we don't have anywhere else to move because we're going to bump into each other. And also because we're so globally connected, it could be a global rather than a regional collapse. Just look how fast the global financial crisis swept around the world if you're not convinced we're not strongly connected. Okay, what are some things happening? Well, as I said, we're globalizing very fast, but bear in mind that 65% of humans still are not in the globalized economy yet, but they're trying to move up very quickly and get in there. Interestingly, 1% of the people have moved beyond the nation state, the globalized nation state view of the world, and owe their primary allegiance to corporations rather than to countries. And this is a trend that is growing. We have resource issues. This is I think, quite interesting diagram showing the petroleum, the oil stocks. The big orange blobs, big orange circles, are how much petroleum various areas of the world actually had originally. The black is what's left. So it doesn't take a PhD in political science to look at USA and the Middle East and understand why there is some quite strong geopolitical tension between those two parts of the planet. And of course, the biophysical part of the Earth is changing. One that's, I think, a hidden but very important change is the loss of biological diversity. It's overshadowed by climate. It's important, probably more important in some ways. Right now, we're estimated to be 100, maybe even 1,000 times beyond the natural rate of extinctions on Earth as measured in the fossil record. And that's without climate change. That's simply due to habitat fragmentation, invasive species, direct predation by humans, and so on. But the future for 2100 is another order of magnitude greater as climate change starts kicking in. So it'll be between 1,000 and perhaps even 10,000 times beyond the background levels of extinctions. And that's led a lot of ecologists to say we are already in the world's 6th great extinction event, but the first one caused by a biological species rather than by a geological event. And of course we have the climate issues which people are worried about, the acceleration of the loss of Arctic sea ice. Now we see an acceleration of loss of grounded ice on Greenland, which leads to faster sea level rise. And the estimates now, the latest ones that came out a couple of weeks ago in the Copenhagen Congress, are that the IPCC projections are a lower limit, and we're going to go above that. A lot of people now are betting on a meter by 2100 and several meters in the next few centuries. And now a lot of people are also talking about these abrupt changes. I said the Earth behaves in an entirely nonlinear way in many of its aspects. And we're starting to identify parts of the Earth system where we can see sudden changes in terms of changes in ENSO, changes in the Indian monsoon, stability of the Greenland ice sheet, I just mentioned that one, collapse of the Amazonian forest. There's some very good modeling based by some good process studies that indicate once you clear land to a certain extent in the Amazon, you will lose the entire forest through self-reinforcing drying processes in the region. So there are a lot of nonlinear changes and a lot of surprises out there. We don't know much about these, and this is an active area for science. So this is leading to this huge debate now that you see everywhere around the world. Whose world really is it? You see the people on the left who, from the WTO and so on, you say, well, yeah, there's some environmental problems, but get the economy even stronger and we'll fix them and we'll just charge ahead. And others are saying, no, we actually have to change direction. There's a very huge debate going on. Very noisy debate. A colleague of mine, Bert de Vries from the Netherlands, just took some newspaper headlines to try to capture the enormous variety of views of the future that people have. We're in an incredibly noisy, incredibly chaotic state. There is no clear way forward yet as far as humanity as a whole. We're talking about cluster civilizations, our common future, the sustainability movement, the end of history, business class, hyper-individualism, market world. And they're fervent believers in all of these possible futures for humanity. Well, I'll close now really by just going back to the climate issue because it is very topical and just showing you where we might be going there. This is the famous NASA Nightlights image of about 2002 or 2003, composite showing the Earth at nighttime everywhere. And again, you see where the energy use is most strongly concentrated, and by the way, where most of the greenhouse gas emissions come from. And if we look at this historical record, 1,000-year record of climate change with the human perturbation on the end, we can put what's going to happen or what might happen into context. Here we've digitized the night lights, and we're going to go forward. So that's a year about 2000. That's the one I just showed you. And if we take a business as usual scenario for 2070, watch what happens. There we go. The world lights up even more. Now, if you take the IPCC so-called A1FI scenario, that's that scenario, and the FI means fossil fuel intensive. It means we keep doing what we're doing. We keep burning coal. We keep building new coal-fired power stations here, China, U.S., keep exporting coal and so on. So most of that additional economic activity, energy usage, is driven by fossil fuels. Then we can estimate with our climate models what that might do. So what I've done here is just taken the 1,000-year record. Here's where we sit just outside variability. But that orange wedge is the suite of projections of the climate models, and on the same time scale. So the point I want to make here is that the rate of change of climate change in the future is way outside anything that our ecosystems have experienced or our civilization societies have experienced. And of course the magnitude just, it says it all itself. Now, I've put some tags on here. These are my own judgments there. They don't belong to the IPCC. The projections do belong to the IPCC or come from the IPCC. So you see here we're committed. We're about 0.7 or 0.8 of a degree above that long-term average. We're committed to 1.3 or 1.4. That's simply due to momentum in the climate system. Even if we shut down emissions tomorrow, around 2 degrees, we're going to see really massive biodiversity losses by our best estimates. Coral reefs will probably disappear. Greenland ice sheet will probably hit that tipping point somewhere towards 3 degrees and so on. In my view, I think if we go up to the upper level there, I think that's a collapse scenario for modern civilization. I think we won't be able to get through that one because it's just too fast and too great a change. So, final comment, sustainability or collapse. We in the natural sciences can say a lot about what climate might do, how fast biodiversity might be lost, what changes to the nitrogen cycle might mean, and hopefully we might be able to tell you a few years down the track how they interact, and we might even be able to tell you a bit more about those tipping elements and where there might be some big surprises. Well, what we can't do is really tell you how to solve it because it's outside our area of expertise. But I will just make this last comment before I turn it over to other speakers, and that is the future really will depend on some very fundamental things, not just on economic instruments, not just on new rules and regulations, but really the nature of our aspirations, our values, our preferences, and our choices. That's really what it's going to take to transform modern human society, and nothing less than a transformation, I think, will allow us to avoid the collapse scenario.
Thanks very much, Will. That was fantastic.